So that is the analysis of a mechanism, and more specifically the kinematic analysis of a mechanism. But what is synthesis? And more specifically here, the kinematic synthesis I am talking about, because we are basically dealing with kinematics first. Now, let them. I like to take an example in case of analysis. I think many of you have seen in your workshop. So you have carried out the experiment or some work in the workshop. So, for example, say carpentry shop or fitting shop. Whether it has been done, the carpentry shop and fitting shop in your
Yes,
first
sir.
and
It's
second.
about
Yes, sir.
different
Yes, sir.
batches, different thing happen
For
because sir, in the
So
second
you
semester
have,
we
second
have
semester
many batches. So
before lockdown, have you gone through any workshop?
yes, sir, carpentry
Carpentry shop, or even
and
if you
machining.
have not,
Yes, sir.
then the carpentry shop, you have to clamp your wooden piece with a vice kind of thing. No, at the end of the table there is a vice.
Yes, sir.
So what type of motion you used to give in the
I have
vice
to rotate.
to clamp that particular wooden block in a vice? What type of input motion you used to give by using your hand?
So rotation.
Rotation motion.
Rotary motion. And what type of motion you are getting at the output end? That means that vice jaw,
Linear.
linear
Sliding.
motion.
Sliding.
So sliding motion. That means your input was your rotary motion and output was your
Sliding.
linear motion or the sliding motion. So how this motion transformation has been taking place?
With the help of
With the help of a screw joint.
threaded screw,
It is the threaded joint
which
or the
attached
screw joint is
to
there
the
in between, which converts rotary motion into the translatory motion. Now, in the mechanism, in that case, a mechanism is given to you, the vice, having the screw nut mechanism like this. Now, you have to find out the relationship between the input-output motion, means how much rotation you have to give to clamp that, or in order to get the desired sliding motion. That relationship you build, that you rotate this much amount, then you will get this much of translatory motion, and if your thickness of the block is this much, then you rotate up to this one. Clear? So this relationship, input output relationship building, is purpose of the kinematic analysis. A simple example I mentioned. There are many complicated examples. For example, the slider crank mechanism or the quick return mechanism. Say how much translation you want so that you will get the desired crank RPM. So that is another issue. That and there also you have to think, that I will tell you just afterward. So this is the building the input output relationship is the purpose of the kinematic analysis. But synthesis is the real life problem. Synthesis having more practical importance, and it is a real life problem. That one problem I like to tell you now. So I don't know whether I proposed that thing in the last class or not. I like to tell you now. Say for example, many of you at least seen in the relatively old computer or even laptop, there is a DVD writer or DVD drive, a DVD or CD drive or CD writer. I think most of you know what is DVD or what is the CD. Okay, so that DVD writer in computer or laptop, you might observe that once you press a particular switch, either in computer or laptop, the DVD writer is coming out from that particular cabinet. Now here I like to give you the problem in such a way. This is not a computer science problem, it is a really real life mechanical engineering problem. Though the computer science engineer, they're claiming the computer is their product, but truly speaking, mechanical engineers have lot of contribution over the computer. Now, the once you press the switch and the tray is coming out, in between there is no magic. There is only engineering and science. Now, I like to give you one problem. Say you have to, and can anybody tell me what actually happening inside? Can anyone unmute yourself and can you tell me what inside is going on? Once you press the switch, your DVD tray or the CD drive tray is coming out from the cabinet. So
There are two motors that convert that run the screws that convert rotational motion to translation motion, and thus we get the sliding of the CD tray.
good. So you have correctly mentioned. So once you press the switch, the motor will start running. Maybe one, maybe two, whatever may be. Now you know the motor having the rotary motion. Now you have to convert that rotary motion to the linear motion of the tray. That means here motion transformation has been taken place. That means it has been transferred and transformed, and that is why inside there is a mechanism. As you know, the primary objective of the mechanism not only transfer but also transform the motion. So here transfer and transform the motion has been taking place. Transfer means from the motor to the slider joint. This is the transfer. And there will be a transform. That means rotary motion has been transformed to the translatory motion or the your linear motion. So that means there is a mechanism. Now my problem is to design or to synthesize a suitable mechanism for the DVD writer in order to convert rotary motion into rotary motion to the translatory motion of the DVD tray. So once again I like to repeat the question. The synthesize a suitable mechanism for DVD writer which converts rotary motion to the translatory motion. So this is your problem statement. Now my question is, this is your problem statement. You can write or you can record. This is your problem statement, real life problem statement. To synthesize a suitable mechanism for DVD writer which converts rotary motion into translatory motion. Now tell me which mechanism you like to use. Suppose you all are entrepreneur, you like to manufacture of the DVD writer in your computer. So tell me which particular mechanism you like to use. Before that, you state your name. Tell your name and you just tell me that which mechanism you like to use.
Sir, Ashish, rack and pinion mechanism.
Rack and pinion, good. So Ashish computer is like to use the rack and pinion mechanism. Somebody else?
Sir, on my Karmakar, I would like to use two rollers on opposite sides.
Two rollers in opposite side, and how it will to convert that one?
Sir, if it means they will produce opposite motion so that it comes out and goes in.
No, only roller. No, roller with something else will be there.
Sir, the roller will be joined with on both the sides of the plate.
Of the
Plate that will come out and go in.
now how it is
Sir,
possible?
we can use threaded joint also.
You can use what's
for
your
the
name?
jaw.
What's your name?
Somadev Ghosh, sir. Somadev Ghosh.
Somodeep or Somojit?
Deep, sir.
Somodeep.
So, yes, sir.
Okay, Somodeep computers like to use the screw nut mechanism. What HP is used? What Dell is used? What SR is used? Have you thought? Have you seen? Have anyone
No,
seen
sir.
that one?
Sir, in traditional DVD writers, rack and pinion mechanism is used.
Okay, rack and pinion is a good mechanism which convert rotary motion of the pinion. That means motor is attached to the pinion is driven by the motor, and once the pinion will rotate, rack will translate, and the tray is fixed to the rack. So this mechanism is a very well-known mechanism in your DVD writer in a particular company. But it is not only the mechanism. Other company may use other mechanism. So that means without breaking your computer or laptop, try to find out which mechanism is there. It is company specific, or you can see YouTube video for that. It's the good way to learn mechanism, to see as many YouTube video as possible, and this is the best tool to learn that theory of machine or any other subject as per my knowledge is concerned. So though I am also believe on the old is gold technology, still I think in this pandemic situation, YouTube videos is the good one. Animation or physical thing, the good one to visualize, because mechanical engineering is basically starts with the visualization. You first visualize, then concept, then interpret, then only you will be the mechanical engineer. No bookish knowledge. So I don't believe that bookish knowledge will serve your purpose. You can score marks, but you never be an engineer. So better you just follow this thing, physically look it without breaking, or you can, if it is not possible, use your Google Baba to search the different YouTube videos of different type of mechanism which is used in the mechanical engineering. Mechanism means it's any subject, not only the theory machine subject. Now that company, you can see the different company use different mechanism. Okay, your friend itself mentioned on the
Sir, can we use slider crank mechanism?
slider crank mechanism is
Sir, can we use slider crank mechanism?
this is the one option. It's another possibilities to use slider crank mechanism. So already your friend has been mentioned 4. That means synthesis means decision making process. Synthesis starts with the decision making. Whether you like to use existing mechanism with some modification, or there are plenty of mechanism is there which converts rotary motion into translatory motion. Which one you like to use in your company or your design? Whether it will be a mechanism like slider crank mechanism, or your what is called rack pinion mechanism, or the screw nut mechanism, or it may be the suitable combination. So synthesis is the process of it is the creative process or innovative process. It is the process of creating a new mechanism or selecting the best configuration from the number of existing mechanisms. And in order to do that, you have to use the analysis. That means you have to use the law of physics, scientific principle you have to use. So determination of optimal dimensions. Once you select the configuration of the mechanism, next you have to find out the optimal or the best possible dimension of the element within the given space. That is possible on the basis of analysis only. Through analysis, motion analysis, through input-output analysis, you can do that one. So that is why, in order to do the synthesis, you need analysis also. And that is why, first you have to learn the analysis, mechanism analysis. So in the next chapter, we like to learn the analysis or the mechanism analysis, or more specifically the kinematic analysis of the mechanism, because ultimate goal is to synthesize a mechanism. But in order to do that one step is to find out the best possible dimension of the elements of the mechanism, and that is possible based on analysis. So without knowing analysis, it is very difficult to synthesize a mechanism. So in kinematic analysis, or sorry, in kinematic synthesis, one has to come up with a new design or design of a mechanism to generate the prescribed motion characteristics. The motion characteristics I mentioned in DBT tray, so that it is the given motion characteristics, you know how fast the tray is coming out, that you can easily design that motion, or you already know that one, or you can measure that one, and how much the RPM of the motor, and how you will convert that RPM or rotatory motion of the motor to the linear motion of the slider with proper motion characteristics or desired motion characteristics. So in the kinematic synthesis, one has to come up with a design of a mechanism to generate the desired or prescribed motion characteristics of the different links of a mechanism. Now, in short, you can say the analysis, these are the techniques that allow the designer to critically examine an already existing design in order to judge its suitability for the task. So analysis is simply a scientific tools or engineering science-based tools, whereas synthesis is the real goal. So that means you have to design a new mechanism or the innovative mechanism to serve a particular purpose, to get a desired motion characteristics. And in order to do that, analysis is required, and that is why next chapter will start kinematic analysis of a mechanism. Now, I like to conclude here by showing that in the today's the age of IT, IoT, or the machine learning, and this era, so the computational tools is very important. So the automation is very important. You know that today's world, even after post-COVID situation, automation is the most important tools. Though automation is used for the last 30, 40 years in the industry, but I don't know whether I have a doubt on the automation used by our academic industry like NIT Durgapur. So there I have a doubt, but I have no doubt that the Indian industry and the industry in the developed country, they like to maximize the use of automation. But being the budding engineer or the future engineer, I request all of you to learn the automation tool, whether your college will support that or not, or teach you that or not, that is immaterial. If you have to learn by yourself, in the higher study, you have to learn many things by yourself. Only a teacher will give some initial momentum to swim across the sea of automation. So the such automation tools which is used in mechanism analysis or mechanism synthesis, or you can say the multi-body system analysis and simulation, the benchmark tool used by most of the automobile and aircraft company, or like Airbus, Boeing, and most of the automobile companies using the Adams. The software name is Adams. So those who are interested in the multi-body dynamics, multi-body kinematic and dynamic analysis of a mechanism, because you know that whether it is the automobile, whether it is the aircraft, it is the full of mechanism, and this is the very first step of your design to synthesize innovative mechanism, simulate that mechanism, and for that benchmark tools is your Adams. And there's some lower version of the tool which is inbuilt within the most of the CAD tools. So in this respect, I like to mention you that there are the different CAD tools that you have to learn first before the Adams. And the CAD tools are like the CATIA and the SolidWorks, which is developed by the Dassault system. So these are the two world leaders, the CATIA and the SolidWorks. But CATIA is a very costly one. It's just like a Mercedes Benz. Its quality or is just like a Mercedes Benz. But same company developed the relatively affordable version, that is the SolidWorks. And it's similar to your common, like it's the Maruti car, Maruti, any say Dzire, Swift, this sort of car, like similar to that, is a low cost, affordable. So any of these two you have to learn. And if you are interested, other software like NX is a very good software. It has a lot of use in both the industry. Both CATIA, NX is extensively used in your aircraft companies and automobile company. Other than that, there is a Creo, there is other software, Fusion 360, something like that. But I think better to learn at least one, and you can start with the affordable one, SolidWorks. Then same methodology you can use for the CATIA as well as the NX. And all the CAD softwares, so whether it's the CATIA, SolidWorks, NX, they are having the motion solver. Many companies, they are taking motion solver, that means the multi-body analysis software code or the solver part from the Adams. They hired from the Adams, but it's a trade secret. They will not disclose that particular thing, that from where they have hired that particular module. So Adams developer are also the developer of their particular model, motion simulation model. So you have to learn, because as you're in the home, I think you have plenty of time to learn, because many other time what like to expand in during your college time or in your campus, I think that day is gone. So that is why that particular time, if you learn the SolidWorks, Adams, I think it will be more beneficial. Once you learn this one, then you go for the finite element analysis like ANSYS, not before that. Now, some of the examples that have been solved in your SolidWorks, CATIA, and Adams combinations, this one, the tractor simulation, has been carried out. See, the same way you can develop CAD model, and CAD model you can simulate it. Or that. Here I like to show an example what I have solved the long back, that is the cricket bowling machine simulation. So you develop the CAD model of the bowling machine, apply the torque or apply the proper kinematic parameter and kinetic parameter over the ball, and you can simulate how it will take a turn after pitching. So few more mechanism I like to tell you just afterward. Before that, I like to start the next chapter, and again once again I will show you few more mechanism. So now I like to start here that kinematic analysis of a mechanism. Can you see that next slide? The next chapter I like to start you first, kinematic analysis of planar mechanism. Can you visualize this?
Yes, sir.
Yes, sir.
We can see.
The slide is not
visible.
visible.
For all the students, it is.
Yes, sir. Yes, it is visible.
Yes, sir, it is visible.
It's visible, sir.
Now, first thing I just like to mention here that the chapter name is kinematic analysis of planar mechanism. Now, important thing here that kinematic analysis. So that part you already know. What do you mean by kinematic analysis? Another important keyword is the planar mechanism. We restrict ourselves within the planar mechanism. Now, what do you mean by planar mechanism? As you know, if all the points of a mechanism move in a plane or move in a plane parallel to a certain reference plane, or in other words, when all points of a mechanism moves in a parallel planes, then that mechanism is known as planar mechanism or plane mechanism. Clear? Both way you can define. So all points of a mechanism move in a parallel plane, or all the points of a mechanism move in planes parallel to a certain reference plane. So reference plane may be any arbitrary plane. So that based on that you can do some kinematic analysis. And when you call this a spatial mechanism, when all the points of a mechanism do not move in a parallel planes, then that mechanism will call the spatial mechanism. But in undergraduate level, here we learn only the mechanics of the planar mechanism, that means kinematic analysis and kinetic analysis of planar mechanism. As you know, the steps involved in analysis, or more specifically design analysis of the mechanism or machine. If body is stationary like your frame or the fixed one, you have to solve static first. That means the equilibrium equation you already know, you have learned in your engineering mechanics class. Free body diagram, in equilibrium equation, you have to write the force balance equation, moment balance equation, and you solve your static problem. Ultimately, you have to find out how the load has been distributed. The moving parts, like your slider crank mechanism, the crank, connecting rod, slider. Cylinder is the stationary part, that is static problem, and if it is the moving parts, like your crank, your connecting rod, slider, so they are moving parts. As they are moving parts, that means there is a motion. Motion characteristics has to be followed. And you have to solve kinematics first. And we have assumed that the body is rigid, and that is why you can solve kinematics separately without considering the cause of motion. But there is a modern mechanism called the compliant mechanism, where your body is not rigid. So you cannot assume that body is rigid. For that, only kinematics is not possible. So the theory is completely different. Here the kinematics, you can separate it out from the total domain of dynamics in the kinetics and kinematics, two separate disciplines you have formed, because that you have assumed the body is rigid. That means distance between 2 points will remain unchanged due to the application of the force or due to the motion. And that is why you can treat the motion parameter without considering the cause of motion, and that has to be solved first, that is kinematics. Once you satisfied the kinematic analysis, then that kinematic parameters, what are the kinematic parameters? Like position, displacement, velocity, and acceleration. That kinematic parameter will be input for your kinetics, where you have to find out, in order to get the desired motion characteristics, how much load you have to apply, or how much force or how much torque you have to apply. And in order to solve the kinetics, or sometimes it is loosely called the dynamics, so that moment of inertia will come into the picture. So inertia force will come into the picture. So once you have solved kinetics, that you know how much force or how much load, that means how much force and torque required to get the desired motion characteristic, next question will be whether that force or the torque I like to apply to get the desired motion characteristics, that can be sustained by our design body or not. And that has to be done by internal effect analysis. Through internal effect analysis, that time you have to find out what are the stress, deflection, twist. So this sort of your internal resistance or internal effect, that has to be quantified by this parameter like stress, deflection, strain, and your is a twist, angle of twist, that has to be evaluated. And with respect to material property, you have to limit its value, maximum limit, and based on that you find out the appropriate dimension of your chosen geometry of the links. So that is the purpose of the strength of material. So be clear about that. What are the purpose of strength of material? And it should be input in strength of material is your is basically output from the kinetics. Output from the kinetics and output from the statics will be the input for your strength of material class. And ultimate objective will be to synthesize or to design the machine component and ultimately the machine. Now, what is the aim that I already explained? Kinematic analysis establishes the relationship between the motion of the various components or the links of the elements, whatever name you call, of a mechanism. So, kinematic analysis establishes the relationship between the motion of the various elements or various links or various components of a mechanism. So, objective is to determine the kinematic quantities. So what are the kinematic quantities? Kinematic quantities are position displacement, velocity, acceleration, and there are one more, that is the jerk. But in this class, we will consider only the position displacement, velocity, and acceleration. So to determine the kinematic quantities or kinematic parameters of a links or element in a mechanism when input motion is given, or vice versa, that means to determine the input motion required to produce the specific motion of the another links, it may be the output links. Clear? So this is your objective. Either you find out the kinematic parameters of the other links when the input motion characteristics is given to you, or vice versa, you determine the input motion required to produce a specific motion to another link other than input link. It may be the output link. And kinematic parameters are position, displacement, velocity, and acceleration. Now, what are the steps you have to follow? That in kinematic analysis, first you have to do the position. From the position difference, you will get the displacement information. Time differentiation of the displacement is your velocity, and the time differentiation of the velocity equation is your acceleration analysis. So these are the steps you have to follow in kinematic analysis. First is the position or displacement analysis. First is the position, space diagram, that is why position. At any particular time instant, what is the position? Now, delta t second, what will be your next position? These two position difference is your displacement information. And time differentiation of the displacement equation is your velocity equation. And time differentiation of velocity is your acceleration equations that you know from your particle dynamics, particle kinematics class in class 11 level physics. Same concept is applicable here, multi-body kinematic analysis. Now my question is, what could be the input for this analysis? It is not like that blindly you can do all these things. Can anyone say what should be the input to carry out all the position and displacement analysis first? What input you should know so that you can start position and displacement analysis in respect of a single solid body or multiple solid body? Can anyone tell? In order to start this particular activity, that means position analysis, what information you need? What should be your input information you need so that you can start?
So the points of contact. I mean, like the joints, like the joints at which the other links are joined.
Links are joined. That point of contact. Good. Anything else?
Dimensions of
Sir, boundary
what type of motion
conditions.
is given? It is a linear or rotary motion, or some other motion, and the magnitude of the motion for this rotary motion, how much the RPM is.
So nature of motion between the links and
The length of links.
Length of link. Good.
nature
So
of
that-
The origin
of
as
the
well.
links.
The point somebody mentioned, that is the contact point. That means the node point you can say, and the link length. So that the link length and the angle between two links at that particular time instant, no? That means link length is the geometrical information. And as you know, in mechanics, it is basically building the relationship between the geometry, motion parameters, that means kinematic parameters, and time. These three important things: geometry, kinematic parameters, that means motion parameters, and the time. Building the relationship between these three is the purpose of the mechanics, or more specifically the kinematics. Clear? So that the information you need, the configuration of the mechanism, that means type of joint, somebody mentioned type of joint used, what will be the contact, and the dimensions, the link length. So that dimension is known as kinematic dimension. If you like to do kinematic analysis, kinematic dimension is sufficient. Not all kinematic dimension is different from the actual physical, actual geometrical dimensions of the components. Clear? Kinematic dimension and the physical dimension of the component is not same, different. Geometric dimension or the dimension of the detailed dimension of the individual component is more complete than the kinematic dimension. Kinematic dimension, I like to explain the what is kinematic dimension. So kinematic dimension, if you see here, if you see the links used, the binary link, ternary or quaternary, whatever may be the links, used in a mechanism, for example, slider crank mechanism. So actually engine mechanism is like this. It looks like this one. So this is your crank, this is your connecting rod is so big, you see, big end, this side is the smaller end, and it is connected with the you can say the piston by rotary joint. There is a pin, and the piston will move inside the cylinder. So this is a approximate shape of the your mechanism or the slider crank mechanism. But when you like to do the kinematic analysis, you draw the simplified diagram. Now, dimension which is important for the kinematic analysis point of view. Just a minute. Now see the dimension which is important for the kinematic analysis point of view, that the dimension, let us say this one, is it important? This how much will be here width, how much is the here width? Because my objective is to build the relationship between how much sliding motion or how much displacement I want at the crank at your slider side, so that we will get the dz rpm at the crank end, and ultimately we will get the through transmission you will get the wheel speed in IC engine. So for that input output motion analysis, that means displacement, velocity, and acceleration, this dimension, this side the dimension, it is not at all. This how much width, this is not at all important. Important is that this center point to this center point, how much is the length? So this center point to this, how much is the length or how much is the distance? How much will be the distance from this center point with the crank, crankshaft? So let us say this is the crankshaft and this point center, and this is the crank which is connected with the connecting rod, that center. How much is this one? So that means in slider crank mechanism, that node to node distance, that means this is node, this is another node. That means center of the joint and center of the joint, this is called the node. So this linear distance is important, center to center distance. Similarly here, this node to node distance is very important with respect to kinematic analysis. Whether how much would be width here, how much will be width here, this one is immaterial. So this node to node distance or the joint center to center distance in case of a binary link is known as kinematic dimension, and that is why you have to draw the kinematic dimension of the in this way you have drawn the kinematic dimension. This is your crank, then rotary, then connecting rod, rotary, and like this way you draw this thing, and this length from here to here, node to node distance, from here to here, node to node distance is important, and that dimension is known as kinematic dimension. So kinematic dimension is the node to node distance. That should be your input for the position or displacement analysis. Based on that, you draw the space diagram. This is called the kinematic diagram, or you can say the space diagram. Clear? So next, what are the methods can be used for kinematic analysis? The steps, first you have to draw the kinematic diagram by specifying the node point, node distance is all after doing that, you have to use methodology to solve the kinematics. So there are the two methods: graphical method, another one is your analytical methods. Graphical method is again different kinematician propose different types of graphical method, like relative velocity method, instantaneous center method, or eye center method. There are the many analytical methods proposed by the different kinematicians for the last 200 years, different analytical methods. So that methods, many method is there. I like to tell you two method here. One is the vector approach, another is the algebraic method. Why algebraic method is also possible? Because it is the motion of all point lying in a parallel plane, and you project it this one in a reference plane, then it will work on a plane only. Because motion of the all points lying in a parallel plane, now project that all the point in a reference plane, then it becomes a planar, and you can easily use the algebra. But if it is a spatial, vector method is more efficient. So I will cover this particular part only, the vector method, because it is more generalized way to represent your mechanism, or you can model its motion. And based on that, most of the CAD-C software or the multi-body dynamic analysis software has been developed. So this is the advantage. Graphical method will give the more insight of your problem, but it is valid for a particular time instant. A particular solution is valid for a particular time instant. So it is a tedious job. Each time instant, if you like to do the graphical method using your either software or by pencil and the set square and all these things, it is a very tedious job. And in exam hall, it will be very time consuming. So that is why, in order to understand that physically how the motion, and that is why a few graphical method, like you can solve the problem, but in most of the time in exam, you have to solve the analytical method, because analytical method you can easily solve manually as well as by writing your own code. So I like to discuss about the vector method. It has importance. It has industry specific importance, because modern software all are based on vector method. So that is why I will prefer the vector method to cater modern generation. So for that, basic vector representation, vector mechanics, or vector analysis, whatever you have learned in your class 11 level physics, please recapitulate by tomorrow and Monday. So Tuesday I like to discuss about the vector method. Okay. Now I like to show you, just a minute. I like to show you some first chapter, some mechanism. I like to share the screen. So I like to show you a few animation of few mechanism. This is called the Geneva mechanism to give intermittent motion. So see the beauty of that particular mechanism. Plenty of mechanism is there. Please go through the animation of that mechanism, like straight line mechanism, pantograph mechanism, quick return mechanism, elliptical trommel. So all this mechanism you should go through its animation, then it will be more clear than the book. If you can follow it to go through the mathematics and analysis part, but in order to understand physically, because I already mentioned engineer should visualize, should perceive, and then interpret. So for visualization, I think that animation, YouTube with plenty of animation, as well the physical mechanism video is there. Please go through that one. Don't wait for me, because I had some time constraint in the class. So that is why it is your responsibility to learn a particular subject physically by seeing your YouTube videos. So this is the ratchet and Paul mechanism. So see the ratchet and Paul mechanism used. You see that here also that intermittent motion. You might see the ratchet and Paul mechanism in many cases. You look at in your automobile, there are use of ratchet and Paul mechanism. So you see the much more video. I just give initial thing that how the intermittent motion uh, is helpful some of the cases. So please go through the different YouTube videos of the ratchet and Paul mechanism. So there are the automobile steering mechanism that I will tell you. Before that, I like to start with the bigger one because you are the student of Institute of National Importance. I like to give you the two big example of mechanical engineering machine. One is the automobile, and much bigger and much complicated is your aircraft. So I think all of you fascinated about the aircraft and in the journey, or we like to fly also, no? So it's the engineering marvels, and more specifically mechanical engineering. Can you hear the sound?
No, sir.
Not clearly,
Yes, sir.
Sound is clear or not?
No, sir.
Not clear, sir.
Not clear.
A little bit you got the sound?
No, sir.
Yes, sir.
Let me tell you. Sound is, you're not getting sound.
No, sir.
Let me try directly the videos, and whether you are getting sound or not, you just tell me. Can you hear? Can you? Is it audible?
No, sir.
Hello?
Sir, in Meet you can't share sound.
Is it?
Yes, sir.
I don't think it's possible.
No, sir. If we share the whole screen, we can't share the sound, sir.
So you just see the modern airplane wings and the tail portion. So see that how the different portion of the wings are having the motion, and that is controlled from the cockpit. So obviously there is a fluid mechanics is important in aircraft. Without fluid mechanics, it's not possible. But there is a big role of mechanism engineer or the multi-body mechanism analysis. So here it has been explained how the lift has been produced, and that is the part of fluid mechanics. But in order to achieve that one, what you have to do in the mechanism level, that is also important. So you have to increase the angle of attack by suitable mechanism, by rotating the aerofoil kind of wings. Same principle used by first flight developed by the Wright brothers. See the flap and slat. Slat and flap, these two things is very important in the aircraft wing. and that motion has to be controlled by the simply mechanical mechanism. So there the technique has been specified to increase the lift, flap and slat. I think many of you have observed that this sort of flap and the slat is movement has been taking place during takeoff as well as during landing. Not only that, during flying also.
Yes,
Here is
sir.
the radar and elevator. Again there is a motion, see. Again there is a motion and it has been controlled from the cockpit. So this motion analysis is the domain of theory of machine. So you have to increase the lift force during takeoff. Lift force should be higher than weight. Either you increase the speed or increase the high attack, and it's by controlling the flap and the slat. Flap and slat, you see that activated to increase the lift force. See that you might see when you are in the sitting in the window side near the wing, not above the wing, near the wing, you can see. So turbofan engine, how it will generate the thrust, there is also a lot of mechanism is there inside. Now where the fuel has been stored in the aircraft, that is also interesting. It is in the wings. Wings and the central portion of the aircraft where wings are connected. So here is let me explain how the aircraft changed the direction. So by changing the radar, you can create horizontal force to change the direction, but it is not recommended because it creates uncomfortable situation for the passengers. So you have to create centrifugal force, and in order to create that one, what is the role of here in the wings, that has been explained here. See that portion, see the little change in this wings, that particular flap. So there is a change in the lift in the left wings and the right wings. So see, because of the different drag, the plane can move like this way, and that has to be neutralized or balanced by this adverse yaw has to be balanced by the, again here, the back side rudder. See the mechanism, the inside below that hole full of mechanism. Here is the input motion is a see, signal will go. Rudder control, the wing flap control, everything is controlled from the cockpit. It is the mechanism driven or the wire driven mechanism. Still today it is using that one. So the landing gear mechanism, you just see landing gear mechanism for the wheel. So that is also interesting thing. See that spoiler. This is called the spoiler. During your landing, how the spoiler motion has been controlled. And you see here, over the jet engine, there is another mechanism by which it can create the huge drag force during landing, so that within the short distance it can stop the aircraft. Now I like to show you that your flap portion, how and a spot flap portion simulation. You just see, and you see what the mechanism inside. So it is the linkage mechanism that you have seen. The planar mechanism is used. Simply planar mechanism is used for the flapper. So I like to show you this particular video. So you can see one use of your plane mechanism and its analysis in the aircraft, and it has a very significant role. Wing have a most important role in respect of your aircraft. So where it is full wings is full of mechanism, full of mechanical mechanism, along with some hydraulic cylinder, pneumatic cylinder is there. Remember a plane is about to take off on there. Flaps you see. So how the wings works, so that has been explained here. Simple fluid mechanics equation has been used. So wings area have a lot of roles. See the wings area, surface area, have a big role in the lift force. Along with the speed, so see how they have increased the area, surface area. See that and here it is a lot of mechanism is used to increase the area when more lift force is required. That means during takeoff, higher amount of lift force is required. Because during takeoff the speed is less relatively, but that is why you have to increase the area and the angle of attack, both you have to increase.
Sir, could not get the with flap and without flap condition.
Hello?
Sir, I could not get the with flap and without flap condition while landing. You just shown it in the slide.
Okay, I will explain afterward. You see first. During landing, you see full of mechanism. This flight control spoil is flight control. The spoil in the wings will open during your landing, just after landing. So you see the full of mechanism where they actuated by the hydraulic actuators. Hydraulic actuator will be your provide the actuating force at the joint, but it is a full of mechanism. Okay, then I like to stop here. If you have any query, then you can ask me. Otherwise, I like to stop. Do you have any question?
Sir,
No,
what is the condition without flap or with flap in the time of landing?
They have shown if you not use the flap, what happens, and if you use the flap, what happens. But every pilot use the flap. Okay. If with the flap, then you can even you can within short interval you can change your altitude. But if you use without flap, you have to take measure from the before that, and if you reduce the altitude well before, then your speed will also reduce. No, that means it will take more time to travel your destination.
Yes, the
Clear?
downward thrust will be lesser in that case.
Huh?
The downward thrust will be lesser in that case.
That may be, but time is also important. No?
Yes. Thank you, sir.
Okay, here I like to show you this one that before going to the big thing, you have to do the smaller mechanism analysis is required, because inside there is a plenty of mechanism, even planar mechanism exist. So that I like to emphasize here. Ultimately, if you join any automobile or aircraft or any other company, this small knowledge, the basic knowledge is required to catch up the bigger one. Okay, thank you.
thank you, sir.
Thank you.
Thank you, sir.